Okay, welcome back. Today we're going to be jumping into chapter 9 dealing with quadratics. Now, as an introduction to this chapter, I had you graph a simple quadratic, the parent function, which is y equals x squared. Um, Now, all quadratics, it's called quadratic because it's raised to a degree of 2. They're going to look differently for each function, but what's going to be consistent is that the degree is always going to be 2. Okay, so these quadratics are always going to look like a u, like we have here, or like a parabola. Okay, so that's what they are called, a parabola. So looking at this u, or the parabola graph, there's a couple different points I want to focus on. First things first, as you can see that this parabola crosses the x-axis. Okay, this is my x-axis, this is my y-axis. Awesome. Now there's a few points that I want to talk about. I want to talk about that point, okay, and I want to talk about that point. Okay, now those 2 points are where my parabola crosses the x-axis, and at those points they are called the roots. Okay. Now, there's other words that you might hear those points be referred to. I will be calling them roots, but they could be called zeros. Um, they could be called x-intercepts and things of that nature. But I am going to mostly call them roots or zeros, and you'll figure out why I call them zeros in the next slide. Over on the next slide. Okay, so now when we look at a parabola, we have a root there, so that's those are two roots. And I want to talk about that point right there. That point right there is called the vertex. Now we talked about the vertex with absolute value graphs, and that point is where your v comes to a point. Very similar to a quadratic, it's where your u kind of turns over and swoops back up or swoops back down. Now that vertex is either going to be a minimum or a maximum point. In this case, if this was like a swimming pool, okay, we have a minimum point down here. A maximum point would be something that swooped up and came back down. It would kind of look like a mountain or a hill. Okay, so now so these are our 3 points that we're going to be dealing with. Okay, now we're going to graph using those 3 points. But let's jump back to the roots. If I gave you those ordered pairs, you can go ahead and graph those. So let's pull out the roots as ordered pairs. So this root would be 0, 0. Good. And that root would be 4, 0. Okay? Good. Now, what do you notice that's in common in both of those roots? Okay, 0, 0 and 4, 0. Um, well, if you look at the y value, both y values are 0. And if you think about any x-intercept, y value is always going to be 0. And that's why the roots are also called zeros, because those are the zeros of the graph. Okay? Now, the vertex in this graph, it looks like about 2, comma, negative 4. So if I have these 3 points, I could graph a parabola connecting these 3 points with a U-shaped graph. Okay, so we're going to practice. So if I gave you those 3 points, if I gave you the roots and the vertex, we should be able to go ahead and graph. So the first thing I want to do, my 2 roots, okay, are, as you can see, 1, 0 and negative 3, 0. The first root I'm going to plot is 1, 0. Start at the origin, 1, 0, x goes first, y is 0. Okay, so that's one of my roots. Okay, then my other root is going to be negative 3, 0. So start at the origin, negative 3, 1, 2, 3, 0, like that. Awesome. Okay, now I have those 2 points. I have to graph my vertex. I'm going to graph the vertex in blue. So if I have negative 1, So always start at the origin, -1, comma -4, 1, 2, 3, 4. I have that point right there. Now, what I want to do is with those 3 points, now you might say, Mr. Green, that looks like a V. I could see where you see right now that it looks like a V, but know that all quadratics, okay, all quadratics look like U graphs. So you're going to connect them as best as you can. There we go. With a U-shaped graph, something like that. Okay, and always keep our arrows at the end, having them as continuous graphs, meaning that they go on and on forever. Okay, good. Let's go and try another one. So example 2. Okay, I have a root here, I have a root there. Let's go ahead and plot them. 0, 0, right there. 4, 0, right there. This all should be prior knowledge, should be easy and simple to plot these points. Go ahead and plot the vertex. Got to do in blue. Blue. There we go. Okay, 2. 2. 4 is up here. 1, 2, 3, 4. Now this looks a little bit different. What did I say? I said that these graphs are always going to look like U's. Now, could you connect a U going like this? No. So this U is actually going to go upside down, and it's going to look something like, not like that. And let me go back. Let's try this again. Nope. Third time's a charm. Let's try it again. Third time's a charm. Come on, Mr. Green. You get the gist of it, that these graphs are going to look like U's. As you get better and better and better at them, you could kind of practice. As you can see, I still do need to work on my parabolas, but as long as they appear to be U-shaped graphs or parabolas, then we are okay. Okay, so I need those 3 points. I gave you the roots, give the vertex. Okay, go ahead. These 2 are money problems. Good luck. All right. Now with these 2 examples of example 5 and example 6, they're a little bit different. Through these examples, I only give you the coordinate for the vertex. What don't I give you? I don't give you the roots. So if I go ahead and plot my vertex, my vertex here, so it's 0, 4, 1, 2, 3, 4. Awesome. Okay, now I need those roots. Now, what does this look like up here? Example 5 looks like, we did this before. This looks like something that is in factored form, right? So if I have something in factor form and I multiplied it out, right? If I multiplied x times x, what would that give me? If you're thinking x squared, awesome. X times -2, -2x, right? I just did that and that, that and that. What about 2 times x? That'll give me 2x. If that gave me positive 2 times positive 2 times -2 is a -4. What happens to these points in the middle? They cancel out. These cancel out, and I'm left with x squared minus 4. Okay, now, I just did extra work. Why did I do that? Why I did that is to show you that this represents a quadratic. Why? Because we have a degree of 2. Now, these are the same things, all right? Okay, this is an expanded form. That is factored form. So if I have the equation of x squared minus 4, it's the same thing as saying y equals the quantity x plus 2 times the quantity x minus 2. Now, if you wrote that, great, but I'm going to go ahead and erase that because I just wanted to show you why we're going to use this as our roots, or to help us find our roots. Now, if you remember that Obviously, a quadratic, okay, most of the time is going to touch the x-axis. It might touch it twice, it might touch it once, it might not touch it at all. But for the most points for this chapter, we're going to have two roots. Now, what do you notice about those two roots? Those two roots have y as a 0, right? Okay, so let's think about that. So I know that my y is going to be 0. So if my y is 0, what is my x value? Okay, well, this is a little bit tough to think about. But all I'm going to do is plug that 0 value in for y. So if I have 0 in for y, I'm going to have x plus 2 times x minus 2. Okay, good. Now, understanding if I had two quantities that multiplied each other, if I was going to output a 2, then something is going to make this 0. Because 0 times whatever this is 0. Or you could say the value of x here, if that makes that 0, 0 times whatever that is going to be 0. So what I want to see, okay, what I want to see is what is going to make the first parentheses equal to 0, okay, and what is going to make the second parentheses equal to 0. So how am I going to do that? I'm going to take each parentheses and separate it. So I'm going to take x plus 2, okay, and I'm going to set that equal to 0. Because I want to know what value of x. I just took that first parentheses and made it equal to 0. Then I'm going to take that second parentheses. It's going to be x minus 2, and make that equal to 0. Because I want to know what value of x is going to make each of those parentheses equal to 0. Okay, so how do I solve for x? For this first one, all I'm going to do is subtract 2 from both sides, right? I want to get x by itself. So I'm going to have x is equal to negative 2. So what does that mean? That means that my root is what? X at negative 2. Okay? And what's that ordered pair? If my x is negative 2, what was my y value? My y value was 0. And what point did I just plot? Negative 2 comma 0. Alright? What about the next one? Next one is going to be add 2, x is equal to 2. So my x-intercept over here is going to be positive 2. What's that ordered pair? That ordered pair up? It's just 2 comma 0. Alright? Now, if you can see, when I input a 2, output a 0, it all connects. Now, I have my 3 points. What am I going to do? I am going to draw a better parabola than I drew before. Hopefully, a little bit better. There we go. Okay. So, I gave you the vertex here, but this one I had you figure out your roots or zeros. So, let's go ahead. I'm not going to go through all of this work. All I know is that I give you the vertex. First thing you're going to do is plot your vertex. So negative 1, 5, 1, 2, 3, 4, 5. Okay. Then I need my roots. Like I said, now I know I need this to be equal to 0. So I'm just going to separate them right now. I want what is going to make this parentheses equal to 0. And what's going to make this parentheses equal to 0. Okay, how I'm going to do that? I'm going to just isolate x, subtract 3, x is equal to negative 3. So what does that mean? Mean that one of my roots is negative 3. That's all that means, right? What is this one? Let's add 1, add 1. I am going to say that x is equal to positive 1. Okay? So what does that mean? That means that that's my x value right there. Awesome. So if I go ahead and write these two ordered pairs, I want to say that this ordered pair is negative 3 comma 0. Okay, and this ordered pair is 1 comma 0. Awesome. Lastly, I'm going to take my parabola and draw it like such. Okay? Hopefully you guys are better drawers than I am, but you guys should get the gist of it, knowing that we have to have our roots, have to have our vertex. With those 3 points, we could graph our parabolas. 7 and 8 are money problems. Good luck, and ask questions if you need them. See you next time.